Okay. So Lagrange error bound. Guys, how do we know which derivative to worry about? N plus 1, but wait, well, who's n?
They give us the third.
There you go. So then we're looking at which derivative?
4.
The fourth derivative, good. But we also have to plug it into the Lagrange error bound formula, yeah? Okay. So the Lagrange error bound formula says that error bound is going to be, thank you, the fourth derivative, because we already talked about y, of z maximized 4 factorial. We're approximating 1.9, right?
Yep.
Minus centered at 2?
Yep.
Cool. So what do we do for the fourth derivative?
We use the h of 4 of x. At 3, because that's our z.
But that's great and all, except why are we doing it at 3?
Because it's constantly increasing, so 3 would be the highest value. But it's centered at 2.
3 would be the highest value, except it is centered at 2. So remember, we're supposed to maximize, if possible. Okay, if possible, remember we have sometimes gone outside the bound if we're doing something by hand and we need a reasonable, rational number, right? If we're doing it by hand, can't use our calculator. But in this one, like technically, the definition says to maximize this on what we're approximating to the center, or the center to what we're approximating. So technically, between 1.9 and 2, careful, you would need to show, although it does not say explain or justify, which I'm a little bit salty about, but maximize the fourth derivative on 1.9 to 2. Technically, you shouldn't say z. Technically, you should say x. Is f quadruple prime of 2. Since, why would the since be?
Well, it's an under approximation, so 1.9 is under approximation, so 2 would be fine.
No, that wouldn't be a justification, but good thinking.
Why are we using it?
Yeah,
Max.
but why is it maximized at 2? Stop talking and look at the problem. Why is it maximized at 2 and not at 1.9? Now, granted, I know you have 2 and not 1.9, but still, how can we say it's maximized at 2?
Because it's increasing.
What's increasing?
The function
H prime is, but that's not enough. H double prime is, but that's not enough. H triple prime is, but that's not enough. Thank you. Since, pretend it's an H, I've just been writing F, is increasing. So that's why we would use quadruple prime, which would be 584 over 9. And then you would plug in over here, 584 over 9, all over 4 factorial. Kiddos, what did I teach you to do? No. Don't box it. Thank you. Okay, there you go. Then you can say check. I've shown it about 3 times throughout the chapter, so maybe you forgot. But what am I trying to prove to you? You can stick it to the man, true? So do you actually have to prove to yourself that that is that? No. But do you need to state it? Yes. Why? That was the objective of the problem. And if you've done your math correctly, will it be true? Yes. So could they argue you on it, aka take off points for it? No, as long as you show it properly. Are we tracking? Okay. Why did I state since the fourth derivative is increasing? What was I proving? Why you can use the fourth derivative at 2. Why did I say the fourth derivative and not the third or the second or the first or the h? If I'm looking at the value of the fourth derivative, I need to know whether or not he is increasing or decreasing. Yeah. In your colored pen, write it just because all the Lagrange ones that I have seen need you to justify. So I just want you guys to be used to it. Kyle. And they don't always say justify or explain Henry's dilemma for Lagrange. So they don't always actually say explain or justify.
Yeah, this
So-
one say explain or justify. That's how it's like to
Yeah, but I've seen FRQs where you get a point for showing the max, and in the answer key it gave y, which very well could have been a part of the point. That's why I want you to write it. Kyle?
But this is a question about the reasoning. Can you not say it's the fourth? Because don't we need the fifth derivative to say it's
We just want the highest value, so if it's increasing, the highest value will happen at the rightmost value.
Like at h,
I don't care if it's concave up or concave down.
but we're looking at like can we use like we said h to the fourth derivative as y?
I could make the same conclusion about h fourth derivative being the highest at 2 if I knew the fifth derivative was positive. But remember, the sign of the next derivative indicates the increasing, decreasing nature of what you have. So the fact that I know this guy is increasing, I know the next derivative is positive, but that doesn't make a difference. Because the problem says it. It says all the derivatives are increasing. Yeah, you're right. I wouldn't be able to know otherwise, except the problem says, I think, does it say all 4 derivatives are increasing? Perfect. Without saying that, I couldn't have said it was maximized at 2. Sorry, that's what I was trying to draw your attention to. I thought you guys saw it. Yeah, and the problem itself underlined the word increasing. All 4 derivatives are increasing. That's the reason I can say, hey, I need it at 2. All right, with that, go ahead and pass it back, pass it over, get it in the tray. Due by the end of the day, but you guys should be totally on top of things because we worked on it so long yesterday, yeah? Here we go. Notes open. 11.1. Hold on. Yes, Kevin. Yeah, just leave your phone on your desk if it's in any pockets.
It's over there.
Okay, perfect. You guys should be able to fill this in with a forever card. Let me give you a couple moments. As long as the phone is left on your desk, then yes. 11.1. 11.1. You guys should have been able to fill this in with your forever card, yeah? Endeavor card. You guys know what I mean. What's the first derivative of parametric equations? dy dx is equal to y prime of t over x prime of t, right? We could also say dy dt over dx dt. Good, good, good? Good, good, good. Here we go. Second derivative. Why is this one harder? Because we're always used to taking derivatives by just taking the derivative. And in a way, that's what you're going to do. It's not going to be in terms of x. It's going to be in terms of t. So you're not going to be taking ddx. You're going to be taking ddt. And that forces us to divide by x prime in order to make everything legal. We talked about this when it was time to talk about this a long time ago when we reviewed all the parametric-y stuff. But quick heads up. How did we get off on life? I have no idea. Chapter 11. Parametric, it comes back. Polar, it comes back. Vectors, they come back. Barely. It's like the easiest stuff of the entire year, barely. Okay, parametric comes back, polar comes back, vectors come back, we're done. Okay? Okay. That's all on an Endeavor card already, right? This is all there? Is there anything different or new that we need to put down? I guess we could do this if you wanted. But it's what we just did. So since we already have it in our Endeavor card, let's just go ahead and play. Because now we have AP parametric stuff. Here we go. It's okay. It's okay. The math, our foundation, remains the same. We're just going to have to maybe be a little creative in how to apply it. Ooh, life. Oh, that can apply. Anyway, when circumstances, aka problems, when problems, aka circumstances change, as long as you have what you have chosen, what you have grounded your life on to be truth, it will still apply, although you might have to be more creative as to how to apply it. Anyway, example number 2. You guys get down the important information. Consider the curve defined parametrically, which you should know just by looking at it. X is a function of t, y is a function of t. Consider the curve defined parametrically by x is equal to t squared minus 5 and y is equal to 2 sine of t for t between 0 and pi. Thank you. Okay, I sketched the graph, but it's been a while since we used our calculator to sketch a graph parametrically, right? So, once you have it, sketch the graph. I did not answer letter A entirely. Exactly. How are you going to indicate which direction it's traced? You got to watch it and see where it goes. Does it go from the right to the left or from the left to the right? It can do either. Parametric graphing does not necessarily go from left to right. That is only functions, not parametric. I should say rectangular coordinates. Yep, that's true. P.S. You probably also want to change your T range. Your T min and your T max. Remember, now we have X's, Y's, and T's. Remember, X stands for horizontal, left, right. Y stands for vertical, down, up. T stands for time passing, right? Huh? Ooh. Depending on your mode, degrees or radians, also remember your T step must be small. Because if you're just checking in at big increments, you're only going to see kind of haphazard parts of the journey and not the in-between of what was going on. Does that make sense? If you're in radians, 0.1 is great. If you're in degrees, 5 is great. Think 0 to 2 pi and 0 to 360 as your gauge. Especially because we have sine of t. Did you change your t min, t max to 0 and pi?
That's what I changed t.
Back in your window. Above the x min, x max, change your t min, t max, 0 to pi. You got it? How many of you guys don't have calculators? Everybody else has calculators?
Oh yeah, I'm using mine.
Okay. Somebody somewhat mechanical, can you get my door to be propped open? I'm saying somewhat mechanical because you kind of have to experiment with the door stop to kind of jam it in and have some fun. We'll try to get some air because you guys are falling asleep. Okay. Kiddos, did you trace the direction? Indicate the direction, I should say. Zero to pi, right, guys? Gabby, is it 0 to pi? Okay. Do you think 0.25 might be sufficient to take steps in between here and here and kind of get the idea? It might be, but 0.1 might be a little better. Either way, something small. Something small. My x equation, let's get rid of all this stuff because it was from an old something example. Probably us the beginning of the year, to be honest. Do you guys see how, hold on, do you guys see how I like the little circle with the line in front? Do you remember what that stands for? Yeah, trace it with the little circle so we can see what's going on. The last thing I need to make sure is what you guys, especially my physics people, need to make sure of all the time, that we're in radian and not degree. Okay, good. I'm going to do a 10 by 10 just because probably I'll see what's going on. And what direction was it going? Probably the way you would have guessed, but could it have been going a different direction? The answer is yes. What was wrong? Did I not put pi in there? I think I did. Oh, it changed to 2 pi when I went to do radians. Thank you, thank you, thank you. All right, all better now, right? Okay, so the last thing we need to do is just show, remember from parametric and pre-cal, maybe you do, maybe you don't. I need my orientation arrows, right? Orientation arrows, I'm good. Okay. Letter B. Oh, this is easy. We get to use our calculator. So the highest point on the curve. Let's go. dy dx. Oh, okay, so what are we going to do?
Take the derivative.
Then you start tracing.
Wait, sorry.
Just table it.
No, but if we keep tracing, it's just because we might actually get the right point.
Why don't we just convert to a
That's not going to help. I mean, can I keep on plugging in t's and guess? But it might be harder than just doing what by hand. What were you hoping that would do?
convert to a normal function.
Pause. It's okay. Calm. Breathe in, breathe out. We're okay. Supportive environment. We know you. We love you. Here we go. B. How do we know where the highest point is? Critical number, aka the first derivative equals, okay. So that feature would have been great if we could have plugged in values for the first derivative and found where it was, but that function works opposite. It said, give me t's, I'll give you the derivatives. We're like, no, we want to give you the derivative and know the t's. So guys, how are we going to solve for it?
Take derivative of y.
Got it. We have to do y prime over x prime and solve for 0 ourselves. P.S. You just saw the calculator can't do it for you on this one, right? All right. So here we go. Y prime is equal to 2 cosine, yeah? Over 2t. We're going to solve by hand? We can. Because this can never make a 0, right? Remember our little pitchfork, zeros or DNEs? We could do it that way if you want for crit numbers. But we know it's a horizontal tangent line, so really we don't care about the DNEs, do we? Okay, so set the top equal to 0. And the top equals 0 at, well, all sorts of places. But inside this interval, won't cosine only equal 0 at? No, wrong one. Pi over 2. Whew! Whew! Careful, unit circle. Alan.
Okay, I'm sure this is a dumb question.
Go ahead.
But how did you know if dy dx was 0?
A highest point, a maximum, on this one occurs at the horizontal tangent. Does that make sense? So think crit number. But we can see the graph, so we're not needing to like kind of not know at all what's going on and look for vertical tangents and horizontal. We can just say the highest point is going to be the max. We see it right there. Let's just find the 1, 0. So t equals pi over 2. We could box and still be totally wrong because of what Noah just said. What did they ask for? The point. T is a time. So we plug it in and we say, what is x of pi over 2 and what is y of pi over 2? Yeah? And we're going to be smart about it and we're not going to simplify. Okay, so we end up with pi over 2 squared. Yes, it's pi squared over 4. Minus 5 and 2. Are they going to want us to do sine of pi over 2 though? Yes. We're supposed to simplify trig. Sine of pi over 2 would be 1. Dun, 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 dun. Yes, final answer if you were checking with an AP answer key would be pi squared over 4 minus 5, 2.
Oh no.
Let us see. Uh-oh, letter B. What did we not do to finish letter B?
Justify.
Four, relative extrema. Sign charts never work, although we didn't even do a sign chart. So there you go, go team. Couldn't we say that the highest point horizontal tangent line, sorry, TL. Wow. That was struggle, I know. Why did I leave out so much? Shouldn't we talk about the sign of the first derivative before, after, or the sign of the second derivative with concavity to justify?
You just did an HDL.
I just did HTL, which is only enough to say a critical number. So how am I able to leave it there for this one example and this one only? They had me do what? There's a graph right there. Look at it. The max is at the HTL. Dun, 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 dun. Now, what if there was no graph, which we almost never have? You have to show the function is increasing to decreasing, aka the change in signs of the derivative, or, that's the first derivative test, that the second derivative is negative or positive at that critical number, and hence denoting a relative max or min. Yeah? Okay, this one time, I'm letting you guys shortcut it because they had you graph it. Yes, any calculus student should be able to, especially the AP graders, look at it and say, oh, duh, the horizontal tangent, done. Letter C, though, some of you guys already kept reading ahead and saw points of inflection. All right, cool kids, come on, it's calculus, points of inflection. Hold on, pause before the genuine question. I want people to be working. Well, what twos?
cosine t to t.
Yeah. Yeah.
So,
Pause, pause, pause. We're getting questions, but some of you are just sitting there and staring at me. That's not what you're supposed to be doing. Points of inflection come from changes in sign of the second derivative which occur at zeros or DNEs of the second derivative, right? Ready, set, go. Yes. The AP graders will never give points for a sign chart. They will give points for the information from a sign chart put into a sentence. So do they need the sign chart? No. Would they need the information from first derivative test or the second derivative? Yeah, written out in a sentence. Good. Gabby. Or DNE.
but how do you know which ones are? Because those are just possible.
Then you have to go ahead and make a little sign chart and check the signs before and after of the concavity. Does that make sense? Okay, you guys are finding the second derivative, right? Why do you think Katrina asked a second ago if these twos could just reduce? Makes it a little bit easier for deriving, right? Taking the derivative, don't you have to take the ddt of the first derivative, hence cosine over t, cosine t over t. Is that okay if I just take the 2's out? All over x prime, which is 2t again. Did you do over x prime like the formula states? You have to take the derivative of the first derivative and all over x prime. Well, not right now. These 2's went away, but I had to take x prime again for my second derivative. Does that make sense?
Yeah.
So bottom d top is going to be negative t sine t. Minus top d bottom is going to be t cosine t. All over bottom squared will be struggle. T squared. Thanks. Yeah. All over 2t. If you guys notice, isn't there a shared t up above that I can get rid of with the denominator?
No, it's 2 cosine. It should be 2 cosine.
Bottom d top minus top d. Oh, yeah. I was going too fast. Yeah, thank you. Life lesson.
Is it not a negative sign?
No, they're both negative. That's good. Bottom d top minus top d bottom. But the derivative of the bottom is 1, so the t's can't cancel, can't reduce, so I need that squared. So then I end up with negative, give me 1 second, t sine of t plus cosine of t all over 2t cubed. Yes, Noah?
I got something a little different. I didn't take out the
2's?
No, I canceled them though. So it's okay. We'll just grab that.
Kyle's talking about the zeros down here, over here. That's good. We should also be thinking about the DNEs. True. However, the only DNE that I see would be the denominator, so when t equals 0, right? Could 0 be a point of inflection? Could 0 be a point of inflection?
No.
It's on the interval, but am I going to look before and after for a change in sign? No, so I can kind of ignore the t equals 0, but what else do I have to consider? Go ahead.
Then when do you test the endpoints?
Intervals of convergence.
No, with like derivatives.
Absolute extrema. Absolute highest or lowest. Yeah. Technically, well, I mean, it's not a bad idea. We could go ahead and do t equals 0 and then t equals, wait a minute, how am I going to figure out the top guy? We're allowed to be using our, so couldn't I change, don't plug it in parametric mode. That's going to be nasty, right? Plug it in function mode. All right, guys. Shh. You guys know what I'm doing, right? Why am I changing my window to be 0 to pi?
Because that's what they wanted.
I'm looking for any zeros in between. Katrina.
You didn't add the negative in there. Or you
Why didn't I?
well, you pulled it out, but
I could divide by a negative, and so it doesn't matter. Does that make sense? Okay. I see 1 0 and 1 alone. Yeah? Nope, I graphed it in function mode. Parametric would have been,
Oh, x sine x.
right, x sine x plus cosine of x. So when I go to find my 0, I could go ahead and go to my, well, that's left, that's fine. And then let's go to pi, that'll be right. You guys know you can type in a right bound, right? That's pretty cool. There it is, 2.7983, etc. So far, I got nothing though. I got work, but I got no answers. Why?
See if it's positive, negative, negative.
But pause. What can I see on my graph of my second derivative? It goes from it meaning the numerator, true? The numerator goes from positive to negative at that point. If the numerator was positive 1 second, what's my derivative? If the numerator is positive 1 second, what's my derivative? Negative. And then if my numerator is negative the next, so would it maybe have been a little bit safer to just throw the whole thing in and then find the zeros? Yeah, it might have been safer. But we're going to technically say since, wait. Do I care which way the sign changes? Oh, so don't go stating whether it was from positive to negative or negative to positive. Just say since, yeah, the sign. And did you guys notice at 0, there was no way the sign was changing? It was up above. It was up here. Then we're fine. Since the sign of the second derivative changes, don't tell me which way to which way, because maybe you would say it backwards, because you would do the numerator, not the whole function. Just say the sign changes at t equals 2.7983. We could just put 8, right? And that would be, I think, does it say what it's measured in? No. A point of inflection occurs. Now, Kyle's asking a very good question. Kyle is asking, so every single point of inflection, you have to find the actual point. We'll pause and look back. What are they saying? Find all points. Do they want just the t value?
No.
Could they have stated, find the t value where the points of inflection? Yeah, they could have, but they didn't. So therefore, we're not done yet. We just know the t. So how do we finish it? Yep, at x of 2.798. I'm going to put a dot, dot, dot. No, we do. I'm just telling you what I'm about to do. Kiddos, you could just plug it into your home screen, or you could, wait a minute. Wait a minute, don't we have these in here somewhere? Can't we go back to parametric? Can't we go to our home screen? Can't we go find, no, you guys are going to be a little sad, because if we do alpha trace, where our little y1, can I do x1 of my, now, maybe I should have stowed my variable though, yeah? Oh well. I'm going to do something I should not have shown you, but that's all right. I'm going to put in the 3 because I know it's more than that. We probably should have stowed it and put it in, but there we go. And we could also go get our y equals. Is that a what? A 3 software? No, sadly it's not. We have like a school license, and we can have it on so many computers. I know, it would be nice, right? I mean, if you have an Android device, there's like a illegal app that you can use. Yeah. Well, I mean, something non-Apple. I think it's pretty much available in whatever you get. But Apple has to be bound by, and so. So we have 2.830 and 0.673. You guys going to keep me honest? 2.830, and what was the y? 0.67. Sorry, I didn't hear it. 0.67. Thank you. Okay, Kyle, yeah? To just what? I mean, it's up to you. I mean, if you already have the functions in your calculator, I would say it would save time just to throw it in real quick. But it's up to you technically. Yeah. Okay. And if you plug it in, don't plug in the rounded version, right? Because if you plug in the rounded, they might take off points, being like you shouldn't have rounded it. Hence another reason. Like put the ... which would be a little messy. Okay. Ooh, something new. Have we talked about arc length this year? And the answer is yes. But we only talked about arc length of functions, not parametrically defined equations. Yep, it's going to be an Endeavor card.
Wait, so we don't have 50 this year?
What?
We don't have 50
Why would you want 50 this year?
Arc length. Wasn't that the little s?
Yeah.
Corey, shush. Brendan, shush. Okay. Arc length. Square root of
Plus f prime of x.
quantity.
Squared.
Got it.
Then which one was the one that was
Pause. Not done yet. What'd you mess up? Now are we good? Okay. So then look at the formula up here. Pretty close, yeah? A little bit different, but remember how I said way back when it had something to do with Pythagorean theorem? And you were basically kind of finding the distance between any 2 points? Ooh. Because that would be linear, but as you make those differences be infinitesimally thin, you're accumulating the little baby lengths of the segments approaching the arc length. Anyway, does it kind of make sense then that you would have x prime squared plus y prime squared? Pythagorean. Just you're defining the horizontal vertical separately, which is totally okay because that's what parametric does. So, ooh, example 3, right? But do not evaluate. We love those, right? As long as we know the formula. But if we didn't know the formula, we wouldn't get it right anyway. So, here we go. The length of the path. What's different? Length of the path. Remember, parametric curves, you're going to have curved paths. That's okay, no big deal. So when you see the length of the path, or how long is the path, or what's the distance on the path, you need to think arc length. This is Endeavor, number. I think it's 30. Wasn't 29 the last one? Oh, I thought I fixed it. Gabby brought it to me. Didn't I fix it?
it's not I did it online, but I think those were like 28 back to 27 and 28.
Yeah, but I went on that one day in class and I thought I fixed it. Okay. Thanks for letting me know. Usually Google Docs update right away, so something must have happened with my computer, which is normal this week. Okay. How do I plug and chug? Just write it, because it's easy, and just be like 0 to pi and say whatever, take the derivative, and whatever, take the derivative. No, that's not going to be enough, and you guys know it. So what am I going to do? I can't just write x prime squared. Take the derivative. Isn't the derivative? Not sine. There we go.
No, it's 3t squared cosine.
Careful.
Square.
Right? Does that make sense? If you don't write the dt, will they take off a point? Yes. You can't write something illegal and have them give you full points. Okay? My ones that shortcut stuff all the time. Hopefully you've grown out of that. If not,
Oh, can we? Oh, no,
do not evaluate. Stop, 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 stop. Example 4. For t between 0 and 13, an object travels along an elliptical path given by the parametric equations 3 cosine of t and 4 sine of t. Hey, elliptical. Parametric equations of elliptical. That was pre-cal. It's going to be horizontal, 3 and 3. And it's going to be vertical, 4 and 4. Well, it kind of is, but I labeled it. Okay, so At the point where t equals 13, the object leaves the path. Ooh. Somebody's spinning, and all of a sudden letting, where's it going to go? Depending on how you let it go, straight, tangent line. Tangent line, right? Shh. All right. Shush. What are they asking?
They want you to find the line at that point when the object leaves.
Not the line. So what are they asking for?
So pretty much the derivative at that point.
The slope of the tangent line is just going to be the derivative. They're not caring about how fast it's changing vertically or how fast the distance is changing horizontally. What they care about is where it's headed. Okay, they want the derivative when t equals 13, right? Is it really that easy? The answer is yes, but did you have to read and analyze a little bit more than we've had to? Maybe. Just a little bit. So y prime?
Equals 3 negative. That's 4.
4 positive cosine. X prime?
Negative 3 sine.
Plugging in t to be? Would that be a calculator problem? The answer would be yes. And you would throw it in. Noah's throwing it in for us. Yeah, it is negative.
2.879.
I know, I was rounding. You could truncate it, 879, or you could round it, 880, either way. Did they tell us time? No. I was looking for seconds, minutes, hours. Guys, parametric, are we kind of getting the feel for it? What else is there to this section?
Nothing else.
Playing with AP stuff. So, this, look. Maybe we'll do some back of the spiral on Monday, maybe?
Yeah.
But what should we be ready to grade?
Homework.
I'm throwing the homework page online as you guys are packing up. We have 45 seconds.